Good morning, everybody. My voice is audible.
Yes, sir.
So let us wait for 2 minutes so that join and we will start the class. Okay. Okay, so 2 minutes is over. So let us start the class. I don't know, only 5 students has joined. What is the cause? I don't know. So let us start the class. Attendance is very poor in DSP. So I have to report to the HOD of your department to take any cause or action, because without 75% attendance, you will be not be able to sit in the examination. So for the second midterm, we will think about something that those who have a low attendance will not be able to sit in the examination. So let us start the class today. Good morning, everybody. Very good morning to everybody. The start of this week, and today we will start our digital signal processing class. Last day we have started the discrete time convolution, or we can tell it as a linear convolution, and we have shown that graphical method of performing the convolution. So I will recapitulate that thing once, and then we will go for the total method and other method of convolution, and then we will go for the our circular convolution and all that facts. So let us start today's class. So those who have not joined, if they will come, I will join them. But the attendance is totally poor, so that is in consideration. So let us start the class. So hope everybody is watching the whiteboard, and let us start our linear convolution chapter. For linear convolution, last day what we do? Last day we take a let's go for the last days. Just a minute, I will share the last day's video so you can understand. So you can see here, we are doing the graphical method of our convolution, and we have taken the input sequence, the input response sequence, then we folded the first signal, and then what we do is shifted the second signal. So like this, we have shifted it. So last day, those who have not understand the procedure, are you anybody is there who have not understand the procedure? So if you don't give a reply, I cannot understand whether you have understand or not. Have you understand it?
Yes, sir.
Okay. So no problem with the linear convolution. You can do it graphically.
Yes.
So if we take the previous example, today is 10/1/2022. If we take the previous example, the output sequence will have y of n equals to 1, 4, 5.5, 3, 0.5, 0.5, -1. This will be the output sequence, and we know the sequence will start from -1 because L we have calculated. So this will be the 0th position. So this will be the output of the problem. So those who have understand, please solve it, and you have to do it. I am not further proceeding with that graphical method because last day we have explained the graphical method and how to do it. And anybody has no such problem, so I am skipping that part. If you have some problem, I can explain it. Next is our matrix method of convolution performing. Matrix method. So in the matrix method, we will do the same thing, but we will use a matrix for that. And this is our matrix. So what is our xn? Xn was 1. I will put the values of xn this side. Okay. 1, 2, 0.5, and 1. This is the xn values, and hn values, I will put the hn values this side. So what are hn? 1, 2, 1, -1. So this is the hn. Now I will multiply each two. So I will get 1 into 1, 1 into 2, 1 into 1, 1 into -1. Next, the next line, 2 into 1, 2 into 2, 2 into 1, just matrix multiplication. The 2 into -1. Next, again, what we will do, 0.5 into 1, 0.5 into 2, 0.5 into 1, and 0.5 into minus 1. And the last one is 1 into 1, 1 into 2, 1 into 1, and 1 into minus 1. Okay. So that will give us, if I do the matrix multiplication, what will give us? This is the HN. This side is 1, 2, 1, minus 1, and this is XN. So it will be 1, 2, 0.5, and 1. So what will get if I do the multiplication? I will get 1, 2, 1, minus 1. 1, 2, 1, minus 1. Next, what I will get? 2, 4, 2, minus 2. 2, 4, 2, minus 2. Next, what I will get? 0.5 into 1, 0.5, 1, 0.5 into minus 0.5. Next, what we will get? ऊपर चला चला गया. So this will be 1, 2, 1, minus 1. This will be 2, 2 the 4, 2 1 is 2, and minus 2. What will be this?
0.5.
0.5. 0.5
1.
into 1. 0.5 into 1. 0.5. And the last is minus 0.5. The next
0.5
1,
minus 0.5.
2, 1, and minus 1. Okay, so we have done this multiplication. Now I will divide it diagonally.
1.
Divided it diagonally. Sorry. Like this. We'll take another color and I will divide it diagonally. So what I will get? I will get y of minus 1 equals to 1. Y of 0 equals to what? In diagonal 2 plus 2. 2 plus 2. That is equals to 4. Okay. Next is y of 1. What I will get y of what? It will be diagonally 0.5, 4, and 1. So that will be here 0.5 plus 4 plus 1. That is equals to 5.5. Next, y of 2. What will be y of 2? Anybody? Y of 2? Yes, what will be y of 2?
3, sir.
हाँ, क्या होगा 3?
3.
हाँ, मतलब 1 plus 1 plus 2 plus of minus 1. That is equals to 3. Next is y of 3. What will be y of 3? 2 plus
0.5.
Yes, 0.5 plus minus 2. So that is equals to how much? 2 and minus 2 gets cancelled, so 0.5.
0.5.
Yes. Next is y of 4. So what is the value of y of 4? 1 plus of minus 0.5. So that means equals to 0.5. And last of y of 5, that is equals to 1. So our answer, what? Y of n equals to 1, 4, 5.5, 3, 0.5, 0.5, 1. So again, it is starting from -1, so this will be the 0th position. So look at this answer and this answer are same. So any procedure you will do graphical or matrix, the linear convolution result will be same. Understand everybody?
Yes, sir.
Yes, sir.
Okay. So this is the procedure of linear convolution or discrete time convolution using matrix method, and the last day we have learned about the graphical method. So hope you have understand this and you have no problem with this type of problem, that is linear convolution.
हेलो सर।
हाँ बोलो।
सर बोल रहे हैं अगर इसमें तो 4-5 को मतलब जो है वैल्यू दिया हुआ है, जैसे 1 to 1 - 1, अगर बहुत ज्यादा रहेगा तो कौन वाला मेथड सही रहेगा?
सेक्शन कन्वोल्यूशन वो भी सिखाएंगे हम लोग। अगर ज्यादा वैल्यू होता है तो एलाइजिंग फैक्टर का प्रॉब्लम आ जाता है। पैरेलल जो मिसमैच होता है, एक ही जगह पे एक ही सिग्नल 2 बार चला आता है तो उसमें मिसमैच हो जाता है। तब हम लोगों को 2 मेथड यूज करना पड़ता है, उसको बोलते हैं हम लोग सेक्शन कन्वोल्यूशन के अंदर। तो वो 2 मेथड होगा, ओवरलैप सेम मेथड और ओवरलैप ऐड मेथड। हम इसके बाद में आएंगे, इसके बाद सर्कुलर कन्वोल्यूशन, उसके बाद हम लोग ओवरलैप ऐड मेथड और ओवरलैप सेम मेथड करेंगे। कभी ऐड करना पड़ेगा 2 बिट्स को, कभी बाद माइनस करना पड़ेगा 2 बिट्स को। तो 2 प्रोसीडियर है जिसका नाम है ओवरलैप ऐड मेथड एंड ओवरलैप सेम मेथड। जब भी बड़ा बिट्स होगा, यहाँ पर 4-5 बिट्स है, ऐसा बिट्स हो सकता है कि 9-10 ऐसा बिट्स हो सकता है, तो उन दोनों के अंदर अगर कन्वोल्यूशन हो दोनों सिग्नल के अंदर, तब हम लोग ओवरलैप ऐड और ओवरलैप सेम मेथड करेंगे, जो सेक्शन कन्वोल्यूशन के अंदर आता है। Okay.
Yes, sir.
So now we will go for the properties of linear convolution. There are some properties of linear convolution which we will use to solve different types of problems. And we have to know the properties of the linear convolution. So let us go to the properties of linear convolution first, and then we will go for the circular convolution. So again, today is so properties of linear convolution. First property is called the commutative property. First property is called commutative property. What does it state? That if x1 n is convoluted with x2 n, mind it, this is not multiplication, this is convolution. This is convolution operator. So if x1 is convoluted with x2n, then we will get x2n is convoluted x1n. This is not vice versa. This is cumulative property. Because actually, what does it mean? It means. Hello, can you hear me?
Yes, sir.
Okay, what we have a network problem. That's why it is disconnected. So let us quickly start the session. Okay, just a minute. We have a network problem, that's why it is disconnected. So we are talking about the properties of linear convolution. And in that properties of linear convolution, we have started with the commutative property. And the commutative property states that what? The commutative property states that properties of linear convolution. Okay, first property is called the commutative property. So commutative property states that x1n is convoluted with x2n gives you x2n. It can be written as x2n convoluted with x1n. Now this is very important. I told this is the convolution operator. This is not our multiplication. So this is convolution. So what is this means? This means it is summation of, this means it is summation of m equals to minus infinity to plus infinity x1 of m into x2 of n minus m. So this means this actually. If we do the equation, this means this. But this does not mean this. What does it mean? It means summation of m equals to minus infinity to plus infinity x2m into x1 of n minus m. So look at the difference. Here the second bit is shifted, but here the first bit is shifted. But two are not actually equal. If I think about it, is not actually equal. But due to convolution property, commutative property, it is equal. So we can change the first bit and second bit as our desired plan in linear convolution. If we have some options that we have, or we have some problem to convert this thing, then we can change it. We will not have any problem of changing it. Understand what I told? Understand everybody? Hello?
Yes, sir.
So that is the commutative property. The next property is called associative property. The next property is called associative property. ASSO CIA associative property. Now, what does the associative property states? It states that if x1n is the first signal which is convoluted with x2n, and there is another signal which is convoluted with these two signals, means x1n is convoluted with x2n, and the third signal x3n is convoluted with the total value of x1n, or the output value of x1n convoluted with x2n. If this happens, so as per associative property, we can write x1n is convoluted with x2n convoluted with x3. So this is associative property. Next is our distributive property. Next is our distributive property. DIS, distributive property. What is distributive property? It says that if x1n is convoluted with x2n, which is added with a signal x3n, then we can write x1n is convoluted with x2n, and the output is added with the convolution of x1n and x3. So this is the distributive property. So these three properties of convolution are very, very important. So everybody, I request to learn by heart of this property. Now, sometimes these properties also come into the proof, means we have to prove these properties. So can you prove these properties? Okay, we have an assignment I'm written here. I will give you in the Google Classroom today. Assignment to prove the properties of linear convolution. So this is our first assignment, and this is on, today we are giving that to prove the properties of linear convolution. We have to prove these properties, commutative, associative, and distributive. Today in the Google Classroom, I will give it, and I will take it on Wednesday. No, Wednesday not, tomorrow. One day is enough for solving this problem. There is no much derivation. So today I will give the assignment, and tomorrow after up to 5 p.m. is your time for submitting the assignment. And this is your first assignment. So next is linear convolution is done. Then go to circular convolution. So you have a 6 minutes left. So every student, please give your attendance first. I want all of your attendance. This is a single class, so please in the chat box, please mention your name to give the attendance. I have already get 2 students. Quickly give your attendance or there will be no attendance for you. One left, only one left. 5 students, I have got the attendance. Okay, so if you give it, you will get the attendance or else. So let us go for the circular convolution. Let us start the circular convolution. We can get disconnected while doing the circular convolution, no problem. We will continue it in the next class. So concentric circle, we name it concentric circle method. Circular convolution can be done in 2 ways. One is matrix method and one is concentric circle method for circular convolution. So we will do here with concentric circle. Our problem is that find the circular convolution of the given data sequence. One is x1 n equals to 1, 3, 5, 7. And another is x2 n equals to 2, 4, 6, 6. The 2 data sequences are given here. There is no arrow marks. That means everything is starting from our 0 position. So that is n equals to 0. This position is, and this is by default n equals to 0. So we have not much tension. So let us do the solution. So for doing the solution, we have to use 2 circles, as the name suggests. It is concentric circle. So we have to use 2 circles. So let us start with the circles. So this is the first circle. Next, this is the second circle. So concentric circular method. So there are 2 circles for solving the circular convolution. One is outer circle, one is inner circle. Okay, now put the bits. Puts the bits here. So Silpi Shah has just entered. So please give your attendance or it will be not be calculated. I am talking to Silpi Shah. If you not give the attendance, it will be not be calculated. So what we are doing, we are giving the x1 values here. So this will be x1 n, or this will be x1 1, sorry. This will be x1 1. First, we will do it anti-clockwise. That means this way. We will put the values like this way. So first is our 0 position. So this is x1 0. This is x1 1. So this is x1 2. And this is x1 3. How many bits are there? 0, 1, 2, 3. Okay. Now the inner circle will be given clockwise. Inner circle clockwise. So this side it will be given. So this will be what? First we have to make the position of 0th bit. The 0th bit position must be not changed. Okay. So this is the 0th bit. X2 0. So less than a minute is there. So if it is clockwise, then it is x11, sorry, x21. This is x22, and this is x23. So up to this, we will get back to you in the next class. This is the clockwise position, inner circle, and anti-clockwise position for the outer circle. So first, made it in mind. So thank you for attending the class. We'll see you in the next class. I don't get the attendance